Hi, I'm Rachel Meyer, and I'm going to be showing you my lemon electrochemical cell fire experiment. Materials for this experiment: 1 lemon, 6 copper clips or 6 copper nails or 6 copper pennies, 6 zinc nails, 6 copper wires, 2 plastic-coated copper wires, toilet paper, and steel wool. Preparation. You place the steel wool on the ground or inside a fireproof pan, which I used, and put torn up toilet paper on top. Roll the lemon on a table to loosen the juices inside. Insert the 6 copper clips into the lemon, roughly 1/4 inches apart, directly across from the copper tabs. Push 6 zinc nails into the lemon, roughly 1/4 inches apart. Once the copper and zinc are inserted, connect the copper and zinc in series circuit connection. Use a copper wire to connect the first copper tab and the second zinc nail. Use a copper wire to connect the second copper tab to the third zinc nail, and so on until it's complete. Connect a plastic-coated wire to the sixth copper tab. Connect the plastic-coated wire to the first zinc nail. Touch both plastic-coated wires to the steel wool and wait for sparks to catch the toilet paper on fire. Video of me completing the experiment. The objectives of this lab: 1. Make a low-voltage wet cell battery to produce electricity out of 1 lemon. Convert the 1-cell battery into a 6-cell lemon battery by connecting the anode and cathode in a series circuit connection. Start an electrical fire by short-circuiting the lemon battery cell by touching the positive and negative terminal wires together on steel wool and toilet paper. Results: I saw no sparks, no short circuit from my 1 lemon. In the example video, the man said his 1 lemon generated 5 volts, but my lemon didn't seem to generate that much voltage, meaning my 1 lemon did not seem to generate enough voltage or current in amps to short circuit the lemon battery cell and start an electrical fire with the steel wool and toilet paper. Nail-to-nail connections were tight, and there were no frayed wires, so wiring didn't seem to be the problem. The copper and zinc electrodes were not touching each other, so that didn't seem to be the problem either. Discussion. Lab objective: produce electricity from a lemon. Discussion. Producing electricity from a lemon. Lemons can be converted into a wet cell low-voltage battery to produce electricity, and here's how. When copper and zinc are inserted into a lemon, they act as electrodes. The citric acid of the lemon works as an electrolyte that separates the electrodes, and very low current and low voltage can be produced for a short period of time. Electricity is generated through oxidation reduction, a chemical reaction that occurs when the zinc dissolves in the acid and produces 2 free electrons, E negative. Oxidation is the loss of electrons and reduction is the gain of electrons. In a battery, the electrode where oxidation occurs is called the anode. Zinc has a lower electronegativity than copper, so zinc loses electrons more rapidly than copper. Therefore, the zinc electrode is the anode and the copper electrode is the cathode. Zinc, metal, and citric acid. Metals differ in their tendency to give up electrons. Opposite charges attract so that the electrons released from one metal will be attracted to the other metal. Zinc has a higher tendency to give up electrons than copper, so electrons flow from the zinc to the copper. In order for electron exchange to begin, the two metals are placed in an electrolyte solution of ions. Acids, like citric acid, can lose a hydrogen ion. The zinc atom breaks apart to a positive ion, zinc 2 plus, and two free electrons. As seen on the diagram below, the zinc ion, zinc 2 plus, goes into the ion solution, citric acid, and the free electrons build up and stay on the zinc metal until a conductor, like wire, is added. When a conductor, like a wire, is added, the buildup of electrons on the zinc metal flows to the copper. The flow of electrons is called electricity. The lemon doesn't generate electricity, the flow of electron does. The copper gains electrons as they flow to the copper metal by way of the conductor. Electrons flow down copper metal and back into the solution where they bond with hydrogen ions that they were released from citric acid and create hydrogen gas H2. Since the copper electrode loses its extra electron to the hydrogen ion in the citric acid, it can accept more electrons from the zinc electrode. This process continues until the zinc is used up and the battery is dead. Electric current is the movement of electrons through a wire and will generate electricity as soon as the electricity has a path to flow from one electrode to another. Citric acid is the lemon reacts with zinc and loosens two free electrons in zinc ion. The oxidation reduction chemical reaction takes place inside the lemon. Zinc metal goes through oxidation and loses two negatively charged electrons. Copper metal cathode goes through reduction and gains the electrons. Discussion lab objective 2. Convert a 1-cell lemon battery into a 6-cell lemon battery by connecting 6 anodes and 6 cathodes in a series circuit. To make one lemon battery cell using one lemon, insert one zinc metal and one copper metal into I need to restart. Insert one zinc metal and one copper metal into one lemon and connect the two metals with a conductor, a wire. Electrodes are zinc and copper. Electrolyte is citric acid and the lemon. Conductor is a metal wire connecting the zinc anode and the copper cathode. Six battery cells and one lemon through series circuit connection. In this experiment, we were to make 6 lemon battery cells using one lemon. Instructions. Insert 6 zinc metals and 6 copper metals into one lemon. Connect the metals in a series circuit connecting anode to cathode to make 6 lemon battery cells from one lemon. A series circuit increases the overall voltage, not the current. Voltage is the difference in electric potential between 2 points, here anode and cathode. Current is the rate of flow of electric charge. Discussion, lab objective 3. Start an electrical fire by short-circuiting the battery cells. When you build up a battery, try to make the current go through a specific path to perform specific functions like light a light bulb. Instructions for the lab was to start an electrical fire by intentionally short-circuiting the lemon battery. A closed circuit has a complete path for current to flow, so things like light bulbs will light. An open circuit will not have a complete path, so it won't flow, and a light bulb will not light. A short circuit is when Current finds a shortcut and takes a different path than the path that was intended. Short circuits are usually made unintentionally. Short circuits can happen when if wires touch a conductive object they're not supposed to, such as each other or steel wool. Short circuits can be very dangerous and can cause fires, explosions, electrical shock to humans, stop hearts from beating, and can cause a lot of damage to appliances and buildings. Conclusion. In this experiment, I was to make a 6-cell battery with one lemon, which would generate electricity through the oxidation reduction chemical reaction taking place inside the lemon using citric acid as the electrolyte, 6 zinc nails, and 6 copper clips as electrodes connected in series circuit. I was then to start an electrical fire by short-circuiting the lemon battery by touching the positive and negative to a terminal wires together on steel wool and toilet paper. The cathode was copper and the anode was zinc. My one lemon was insufficient for short-circuiting a battery and starting an electric fire. Sources of error. It is possible that connecting 6 sets of electrodes in a series circuit within the same electrolyte did not create 6 battery cells, so did not increase the voltage to 5 volts. It may have been more efficient to connect 6 lemons in series circuit to increase the overall voltage to 5 volts. Or if you want to use one lemon, it may be more efficient to cut one lemon into 6 sections to create 6 battery cells and connect them in series to increase the overall voltage to 5 volts. This concludes my presentation. Thank you for watching.